Hi everyone, in today's lesson we're going to talk about how to create two-way tables to determine probabilities. So before I begin this example, I'd actually like you guys to pause the video, jot down the problem, and then jot down this blank two-way table so that you're ready to fill it in when I go over the example. And then hit resume when you're ready for me to begin. Okay, so here's my example. It says, in a class of 30 students, 6 have a brother, 12 have a sister. There are 14 students who do not have any siblings. So question number 1 says, what is the exact probability that a student chosen at random from the class has a brother and a sister? All right, so we have to take this information from the example and put it into a two-way table so it can make this question easier to answer. So I'm going to break it down slowly. It says in a class of 30 students. Well, 30 students is my total, so that must go down in my right quarter. That's your grand total. Then it says 6 have a brother and 12 has a sister. So we need to set up our labels on our two-way table. So we know that the grand total will go to the right here and bottom left here. So, well, what do we have? We have people that have brothers and have sisters. So all we're going to do is say, in this first box up here, has brother. So there will be people that have brothers, and then there are people who do not have brothers. So do not have brother. We'll go here. Then there will be people that have sisters. And then there were people that do not have sisters. So once you have all of that set up, then it's actually relatively easy to put the information in. So it says 6 people have a brother. Well, if this is my have brother column, then shouldn't the grand total of people that have a brother be here? It says 6 people have a brother, so 6. So we're going to put 6 here. Then it says 12 people have a sister. So being that I have 12 people that have a sister, here's my have a sister row. So the grand total of people that have a sister will be 12. So I can go ahead and put 12 here. Then it says there are 14 students that do not have any siblings. So that must mean that I don't have a sister and I don't have a brother. So if I don't have any siblings, I'm an only child, right? I don't have a sister, but I don't also have a brother. So this is the intersection of these two rows and columns. So right here is where 14 would go. So now we should have enough information to backtrack and fill in our two-way table. So I'm going to start here. If there are 12 people that have a sister, how many people don't have a sister so that it adds up to 30? Well, all you'll have to do is 30 minus 12, and that actually gives us 18. And then now that helps me fill in this number. If I have 14 people that don't have a brother, and I need this number plus this number to add up to 18, 18 minus 14 must give me 4. Well, then now I have this column. If I have 6 people total, 4 don't have a sister, then if I subtract 6 minus 4, I should get 2 that have a sister. And then this column needs to add up to 12, so 2 plus 10 gives me 12. And then down here, if we add 10 and 14, that gives me 24. And let's just check it out and see if it works. Does 6 plus 24 add up to 30? Yes. So my two-way table is now complete. So let's read it. What is the exact probability that a student chosen randomly from the class has a brother and a sister? So a student randomly chosen. So they're not telling you specifically anybody. So we have to use our grand total, right? So we have 30 students total, and we want to know how many of them have a brother and a sister. So let's look. Who has a sister and who has a brother? So has a brother, has a sister. It's the intersection of these two columns and rows. So 2 people have a brother and a sister, therefore my probability is 2 out of 30. And again, I'm asking for an exact probability. So exact means to just reduce that fraction. So go ahead, type 2 out of 30 into the calculator and get a reduced fraction, and then hit resume when you're ready for the answer. Okay, so I got 1 over 15 is the exact probability that that would happen. All right, let's try another example. All right, so same scenario. I just repeated the two-way table so we can use it as a reference. Question is saying, what is the exact, so same as before, make a fraction, exact probability that a student who has a brother also has a sister? So this wording is really, really tricky. They're saying, of the people who have a brother, who also has a sister. So you have to use your grand total of who has a brother already. So that grand total is 6. So of those 6, who of those 6 has a sister, which is 2. So this probability is actually 2 out of 6. So I'm going to repeat that because I feel like that's a little confusing. So again, it says, what is the exact probability that a student who already has a brother, this part is given. The student that has a brother, this is your given information, right? It's giving you that this person has a brother already, and then of those people who have a brother who also has a sister. So I'm using my total of brother and saying the people that have a sister is just 2. So 2 out of 6. And exact probability just means to reduce the fraction. So 2 out of 6 will reduce to 1 out of 3. So that's the probability. All right, let's try another one. What is the exact probability that a student chosen at random from the class has a brother or a sister? So notice I'm not narrowing down your total. I'm just saying, what's the probability that a student chosen randomly? So that must mean we're going to use my grand total, which is 30. And we want to know what's the probability that a student chosen at random has a brother or a sister. So in order to have a brother or a sister, you either have to have a brother or a sister, or you theoretically could have both. So let's highlight the ones that make sense. So 2 people have a brother and have a sister, so that's okay. 10 people have a sister but don't have a brother. And 4 people have a brother but don't have a sister. And we can't include this one, which is doesn't have a brother and doesn't have a sister, because we want to know who has either or. So all we have to do is add these 3 pieces together and we get our answer. So it's 2 plus 4 plus 10 out of the total of 30, and that's 16. So 16 out of 30, you can reduce that because it's asking for the exact probability. So go ahead, type that into your calculator and get a reduced fraction, and then hit resume when you're ready for the answer. Okay, so you should have gotten 8 over 15. And that is your reduced fraction. All right, last example. What is the exact probability, fraction again, that a student does not have a sister? Okay, so again, they're not telling us to reduce the total. So 30 is my total still. And I want to know the exact probability that a student does not have a sister. So let's see. This whole column or row here is actually not good because everybody in this row has a sister. So we want to know who does not have a sister. So does not have a sister. So does not have a sister but has a brother. This one's good. We can include this one. Does not have a sister, does not have a brother. We can include this one. So then our grand total here is 18. So 18 out of 30 would be our final answer. So we can actually go ahead and reduce that. So 18 out of 30 in the calculator, and then reduce that fraction and hit resume when you're ready for the answer. Okay, you should have gotten 3 out of 5. So the probability that a student does not have a sister will be 3/5. All right, that's it for two-way tables. If you have any questions, now's a good time to jot them down. Otherwise, we'll see you in class tomorrow. Have a good night.